On to problem number 10 of the MIT Integration Big Qualifying Exam 2014, which is the definite integral from x equals to -1 to x equals to 0 of x squared over x minus 1. So this is an interesting problem. We'll have two methods on how to solve these. I hope you hang around and see how we may be able to attack this problem. So our problem is as shown here. Now, the first method that I'm going to use is, since our integrand is an improper fraction, and that means the denominator, the degree of the polynomial, the numerator is greater than that in the denominator. The first thing that I would do is do long division, and that is divide x squared by x minus 1. So when you multiply x minus 1 by x squared, we get x squared minus x. And the difference between x squared and x squared minus x is x. Then again, you multiply x minus 1 by 1, we get x minus 1. And the difference between x and x minus 1 is positive 1. Therefore, x squared over x minus 1 is equals to the dividend, the result of the division, which is x plus 1, and then the fraction, the remainder, which is 1 over the divisor, which is x minus 1. So this is our new, which means that our integral from x minus 1, x equals to -1 to 0 of x squared over x minus 1 is the same as the integral from x equals -1 to 0 of x plus 1 plus 1 over x minus 1. So I would like to separate this into two separate integrals. So, and that it's for a reason. So I'll use color blue to demarcate our second integral. So let's see what the yellow integral is. The yellow integral is the same as x squared plus x. So integrating x is is the same as x squared over 2. Integrating 1 is x, and that's -1 to 0. Okay, so let's substitute everything in there. So this is the same as 0 into x squared over 2 is 0. 0 into 0 into x is, so this is the more minus limit x tending to -1, x squared over 2 plus x. Okay, so we have our integral being equal to limit x tending to 0 of x squared over 2 plus x minus limit x tending to -1 of x squared over 2 plus x. So which is 0 minus a half -1, which is the same as negative a half times a half, which is a half. Now for the second integral, See, if we plot this out, we have an asymptote at 1. And so as x decreases, we have a negative, we have something like that, right? And then on the positive aspect, when x is greater than 1, we begin by very small value close to the asymptote, and as x tends to infinity, the graph tends to 0. So, but we are asked to find the area between -1 and 0. So as you can see, the value is negative, right? And when in, so our expression, this value here is negative in the domain we are looking at. I want to deal with the positives when integrating. So in that domain, this integrand is positive, but we have explicitly now pulled out the negative sign. So this becomes negative natural logarithm of 1 minus x. And obviously this and that interact, but let's put the limits there. So we have natural logarithm of 1 minus x, because this and this have cancelled, -1, 0, so that this becomes limit as x tends to 0 of log of 1 minus x minus limit as x tends to -1 log of 1 minus x, which becomes, as x tends to 0, we have log of 1, which is 0, minus, as x tends to -1, log of 1 minus -1, it's log of 2, so we have log of 2, so which is equals to negative log 2. So what this tells us now, that our original integral, which is x squared over x minus 1 dx, equals to the integral, okay, obviously -1 to 0, -1 to 0, -1, it's the blue integral, is now equal to, said we found a half here, positive a half, and for the case of the blue integral, we got negative log 2. And here, ladies and gentlemen, is our final answer. So this is the end of method 1. So let's see how we may be able to handle it with the second method. So method 2, this is both an easy but intricate method. So integral from x equals to -1 to 0 of x squared x minus 1 dx. So this is the same as negative x squared 1 minus x dx. So we know that if you have a geometric series, So we have the first value, and you have 1 minus Rn plus 1 minus R. Okay. Now, as limit for when n tends to infinity of would mean that you just have 1 over. For the instance for which a is 1, we would have 1 over 1 minus r. And this is very similar to what we have here, right? So negative from x equals -1 to 0 of x squared over 1 minus x can be expressed as x squared infinity k of x to the power k, right? So which is the same as negative integral and we can always take the integral sign inside and we can keep going on since we have um, k over 3 m, which is equals to negative. Cancel out. So we're left with this is our answer. Now we can stop there, but we can even make things more interesting because what this essentially is k is equals to 0. We have -1 over 3, 1 over 4k equals to 2, 1 over 5, 1 over 6, and so on. And but we know the Maclaurin's or Taylor's expansion of of that of 1 plus x, sorry, not x squared, is x minus x squared over 2 plus x cubed over 3 minus x to the power 4 over 4 and so on, such that log of 1 plus 1, which is 2, is equals to 1 minus a half, a quarter, and so on and so on. So what we see here are similar patterns, right? In such a way that since we've seen log 2 to be 1 minus a half plus a third and so on, such that negative log 2 is the same as, and this part here is just positive a half, so it's negative a half minus a third plus a fifth. So what that means is equals to since we started from here downwards with this, it means we are adding a half to log 2. So in other words, our integral is equals to a half log 2. And that, ladies and gentlemen, is our answer. So thank you very much for your attention. Until next time, bye-bye.